Hello, my name is Randy Fowler. I'm the president and chemist of Metal Surface Technologies in Cleveland, Tennessee. What we have done is we have designed and developed a field analytical portable test kit for a material known as sodium dimethyl dithiocarbamate, or DTC, mercifully. It was developed after World War II by the Union Carbide Company as a pesticide and herbicide. In the late 70s, it was found to contain reduction properties, which it was able to pull metal ions out of wastewater at companies, metal finishing companies, which this one is, circuit board manufacturing companies, and it's sold millions of gallons around the world. It is sold to treat industrial wastewater. As of today, as of right now, there is no portable quantitative method for analyzing this material. You can analyze it several different ways using very, very costly lab instruments. You have to go through training. The operator, the chemist, or the technician has to be trained in it. And you get your results in a few days. Here with this test kit, I have two different types of test kits here that I've developed. They're the same kit, but they're just different containers for different shelving needs. This one will cost around $50. You can get a result in about 2 minutes, I believe it is. And I'm going to illustrate, or attempt to illustrate, the method for analyzing DTC. In the sample vial, we have a 15 milliliter sample of DTC, which is known to contain about 100 parts per million. The formula, the DTC formula in this sample is 100 parts per million sodium dimethyl dithiocarbamate. And I am going to go through the process here. We have a color indicator. We have some titration reagents, 2 bottles of those, so I'll put this one out of the way here. I'm going to extract the sample into the direct reading titrator, zero it out, and let's see what we've got. First thing we have to do, of course, as all good chemists know, is add the color indicator. 1 drop color indicator. It'll react with the sulfur that's in DTC to form a visible color change, and we will basically titrate it back. The reagent, the titration reagent, actually destroys the molecule that is formed by the color indicator and the DTC reacting together. Actually, I'm going to put the cap back on so we won't splash the sample all over the place. There we go. And we're going to just titrate this baby right on down. You can probably see the color starting to bleach out a little bit, to oxidize out rather. It's not bleaching, it's oxidizing. Down we go. Lighter and lighter. We're going to titrate it until no color remains, until all evidence of the yellow cast or hue has disappeared, which is at this point right now. Actually, that sample contained 120 parts per million of DTC. I thought it was around 100 parts per million. It was a guess at first. We now know it contains exactly 120 parts per million of the DTC molecule, of the DTC formula. So that's what we've developed. It's actually frighteningly accurate for something this tiny. That's it.